reactive ion etching system model 10NR. This system is included with a mechanical pump and the interface box for the powering up the mechanical pump, and it also has a gas leak detection and alarm system. This particular module is to be customized to the gases that are being used at the final installation site. This particular demonstration is for the demonstration of the Samco reactive ion etching machine. However, this controller, the sensor alarm controller system SMC model 5000 should be powered up using 110 volts AC in order for the system to power up, because it is interlocked with the system here. The system is centrally controlled by an Omron PLC, and it is fully operational from the touch screen here. Other than the touch screen, there are a chamber lid open close switch here, and the gas hood door, which is this door, will open whenever it is necessary to change the sample or place a new sample or remove the processed wafer. This door needs to be opened. The system power is turned on by using the on button here, and this off button is to turn it off. And there is an EMO switch here to turn it off in case of emergency. The system uses ENI power supply for 300 watts, and also it has a turbomolecular pump, Pfeiffer brand, and there is a automatic pressure control valve made by VAT, and certain lines on the gas lines can be heated, and there are controllers available here. This maximum set point on these controllers, temperature controllers, is 60 degrees Celsius, and Advanced Energies ATX 600 matched network controller is used in this machine, and the network interface box is over here. The main power to the machine is 3-phase 208. This is the main plug, and this is the power going to the rotary pump interface box, and the interface box is also connected with the control signals to and from the PLC via this connector here. There is an additional connector here which should be in place in order for the system to run. It can be used as an external interlock. A contact can be used on that, and this is the 110 volts power supply going into the system for the gas detectors. And there is a 208 single phase output coming out, and this power goes to the matching network controller. This is the mechanical pump used to rough out the chamber, and it requires formalin oil, and during shipping the formalin oil is not allowed to be left in the pump, so it will be shipped after draining the formalin oil. The system electrode, the bottom electrode is cooled, along also the turbomolecular pumps are water cooled, and I'm using a standalone chiller here. These are 1/4-inch lines, and the chiller water is to be maintained at about 20 degrees Celsius. This is the main controller, the Omron PLC Sysmax C200HG. The system is centrally controlled by this. There are analog signals coming from these analog boards, and there are digital input and output boards here. All the mass flow controllers are enclosed inside this closed box, and at any point of time before proceeding to open this box, the system should be powered down, and after verification of the mass flow controllers for any leaks, the system can be tested with the cover open. There is no interlock or any door limit switch on. These are the two industrial transmitters, gas detection and sensing, and the signal is a 4 to 20 milliamperes coming out of it going to the SMC 5000, and these gas detection and transmitters are essentially used to check in case if there is any leakage in the mass flow controller area. These transmitters could be customized to suit the end user's requirement, and this particular demonstration do not include and the testing of these gas detectors, because we can only use in our facility argon and nitrogen. Only inert gases are allowed to be used in this facility at bid service. So after hooking up all the process gases, an exhaust can be connected here to this port. And any waste gases can be vented to the atmosphere. Right now I have selected the abort process command, and the system, which was under high vacuum, is now being made ready to set the chamber at atmospheric pressure. After this, I'm going to open the lid and demonstrate the rest of the process, how to begin the sequence and run the machine. So from the main menu, I have selected to shut down the system just to demonstrate. There is a full range gauge that indicates the chamber vacuum level from atmospheric pressure all the way down to high vacuum. And there is a diaphragm gauge or a Baratron pressure gauge for the process pressure. The pressures in this system are displayed in Pascal, and there are this indicates the rotary pump, DRP, and turbomolecular pump. So as soon as the shutdown sequence is initiated, the turbo pump is being now in the deceleration mode, and once the turbomolecular pump comes to standstill, that's when the system will be ready to completely shut it down. The turbomolecular pump controller normally displays about 830 Hertz frequency when the turbo pump is running. Right now The speed is decreasing gradually. And once the speed comes to 0, that's when the system is ready to shut down. So I'm going to start the system from the power up sequence for demonstration purpose, and that will also indicate how fast we can turn on the system and get ready for the process. In normal operation, the adaptive pressure control is always in position mode, and either it will be in closed or open. While evacuating the chamber, it will be in open mode. Right now, since it is in shutting down, it is in closed mode. But actually, at the time of process, the pressure controller will go to pressure mode, and it will regulate the valve in such a way to stabilize at the process pressure. Usually the process pressure is about 5 to 15 pascals. Okay? The button is illuminated and it indicates I can open the door. So in order to open the door, we have to first press the button and then press the lever on the handle, and then we can open it. So this is the actual process chamber, and for the safety of the operation, normally it is disabled to open. So in other words, only when the door is closed, only then we can open the chamber lid. Also, well, only when the chamber is at atmospheric pressure, the system will allow to open the chamber lid. So this is the MKS Veritron model 622 pressure sensor used for the process pressure. There is an isolation valve here, and all these vacuum lines and these couplings, they have O-rings, and the vacuum lines have to be clean. So during routine maintenance, it is advised, as per the manufacturer's suggestion, we have to open these couplings and make sure the lines are not clogged up or dusty. And this is the gate valve, the pressure regulation throttle valve, and the turbomolecular pump is here, and it is water cooled. So this is the final screen when the system is ready for either startup or turning it off. So I'm turning off the machine. So I'm going to demonstrate how to turn on the system and power up. So first is, once the compressed air and nitrogen, everything is connected, even the water lines are connected and the water is flowing through the machine, turn on the main circuit breaker. And then turn on the main power to the system by using that key. So at this moment, the system is powered on and the rotary pump is ready to be turned on. So we have to press the start button, and that will start the mechanical pump. At any point of time, if the pump is turned off, this can be used. The stop button can be used. So once the pump is on, after making sure the pump is on, you start the system by pressing system startup. When the system startup button is pressed, the system on LED will indicate here that the system is turned on, and the screen The startup system sequence screen is indicated here, and the valves will turn on sequentially in order to pump down the chamber to the desired vacuum level once the automatic pumping sequence is selected. So this is the main menu screen. So from here we can proceed to testing the system in manual mode, where the manual menu screen will appear. Here we can manually enable or disable a gas and also enter the gas flow rate and then run the whole process sequence manually. And in order to regulate the pressure, the gas evacuation button has to be turned on. So as soon as we turn on the gas evacuation button, first open the isolation valve, or the diaphragm gauge monitor's isolation valve. Both can be turned on. And we can also turn on any gas by selecting the gas. So right now, with the diaphragm gauge on, I'm able to turn on the gas, and the gas is flowing to the set value, which is 25 SCCM. And then I can regulate the pressure to the process pressure selected is 15 millitorr, and right now the diaphragm gauge indicates about 14.6 Pascal. I'm sorry, this is 15 Pascal. So by pressing the isolation, turning off the isolation valve 1, we can turn off the sequence and go to the main menu. So there are other screens available here. These are the offset settings. So the RF forward powers, what is the tolerance limit allowed? It is set currently at about 50 watts plus or minus, and the reflected power also is set slightly less than 50 watt is allowed, and also the detection time in how many seconds it will detect the power level is also adjustable. So similarly, the gas flow tolerance limits and the pressure tolerance limits can be entered here. So that's the system shutdown button there, and the process gas selection. So in case if a process gas is to be changed, so this is the screen from where we can select any of the gases appearing on the screen. There are 13 gases that we can select from this menu and set the maximum level as well. There are some internal timers. These are the timers in the process sequence that are used to the duration used to reach the set point, or the high vacuum time, or the gas duration desired to adjust the gas stabilization. So it can be set any value if the gas stabilization is taking longer or shorter time, we can reduce the timing here. So after select a parameter, like I have selected number 4, so we can change from this keyboard. We can enter the values. So after changing the numbers, if you press enter, the new value will be retained. So I'm going to the automatic mode, and then selecting a recipe here, say recipe 9, which already I have entered the process parameters. At any point of time, a process can be disabled by pressing the reset button, and then press the buzzer stop key and confirm it. And now I'm going to purge the chamber. So every time the system chamber is purged, the residual gases inside the chamber will be pumped out first. So right now the chamber is purged and it is ready to open the lid. So I press the chamber lid open button, and after some time delay it will allow me to open the gas door. So right now, up to the purge, I'm pressing the open button. You can see the chamber door open. And then after the chamber door opens, the unlock light will turn on here. After a time delay, once the unlock light is on, press the... Now this is inside the process chamber. I have a 8-inch silicon wafer loaded here. There is also a quartz wafer carrier. So this is the bottom electrode, and RF is fed to the bottom electrode, and this is the upper electrode, and the gases are delivered through this electrode here like a shower head. So first place the quartz wafer carrier, and then load the wafer on it. And after loading it, you have to first close the door, and once the unlock light is on, press the close button and hold it until the door closes completely. Now we are ready to proceed to evacuate the chamber, either by pressing vacuum button or process button. So we are going to proceed with the process. So the last recipe we selected was 9. So I can change the recipe to 8 and decide. So here in this screen, at any point of time, we can select a recipe and start editing every step on it. So in a recipe there can be more than one step. There could be 4 steps, and a purge step can be included at any point of time. And once you select a step, the first item in the list will be selected, and we can go down like this and select a value here. So we can enter the values here, and then so right now I have 3 mass flow controllers connected to argon gas, 4, 5 and 6. So I'm going to select the process pressure as 10 pascals, and then RF power as 250 watts, and the process time, so it shows hours, minutes and seconds. I can select 1 minute. If you don't like it, clear it and press 2 minutes, press enter, and 30 seconds. So after, likewise we can change the values in every step. So we can create a process in such a way we can first process in step 1 and then go to the step 2, and then third step we can include a purge step where at the end of the step the chamber will be vented to atmosphere. So I'm going to select the recipe 8 now, the one that we just entered the new values. So the process begins with the rough pump down first. Initially, both the full range gauge and diaphragm gauge both will be reading the values, and once the high vacuum is reached, the system actual process will be monitored by the diaphragm gauge. I pumped down the chamber overnight. The system pumped down below 5 into 10 to the minus 4 Pascal, which is better than 3 into 10 to the minus 6 torr. So extended period of pumping down will help to evacuate the chamber better, but the normal desired pressure the process to begin pressure set value is 4 into 10 to the minus 3, which is 3 into 10 to the minus 5 torr. This is the RF matching network assembly. Here there is an inductor. There are a couple of inductors here, and there are 2 capacitors. One of them is parallel and another one is serial to the input RF signal. These variable capacitors are motor driven, coupled to the motors via these belts on this end here. Now there is a ceramic capacitor, a fixed value capacitor, right now installed under this screw here. Now at the time of tuning with the process gases, if necessary, an additional capacitor has to be installed near these ports provided here. I will include a 50 picofarad and a 100 picofarad capacitor just in case if necessary. And also a jumper plate will be included, which has to be connected like this and somehow clamped. So by this jumper we can vary the inductance, and these things, changing the capacitors and the jumping this inductor, to be done only if necessary to tune the RF matching network. So our aim will be to achieve maximum forward power and minimum reflective power during the reactive ion etching process. So chamber is pumping down in high vacuum mode. Once the full range gauge displays 5 into 10 to the minus 3 Pascal, the diaphragm gauge will take over and the system will start to enable the gases and begin the actual ion etching sequence. So right now the full range gauge is disabled by isolating it with an isolation valve, and the throttle valve is adjusting. So it has come to pressure mode and it is trying to set the pressure at about 10 Pascal, which is, it is actually reading it as 9.8, and right now this valve motor indicates that it is in regulation mode. So all the 3 gases selected are enabled now and the values are stabilized. I have argon gas going through each mass flow controller here. So we are still in the step number 1. So once the process gas flow and the pressure is stabilized, the tuner network kicks in. Right now I have it in auto tune mode. In case the forward power is not close to the set point, but the reflected power is above 50 watts here, then you have to select the manual mode and adjust these parts so that we will see, we will be able to lower the reflected power. So I'm trying to tune it manually. The manual tuning takes a few moments, but if you switch to auto tuning, it tunes better. So the manual tuning is to be done usually with a forward power at about 100 watts, and then once you set at 100 watts, then only by adjusting the shunt position knob, we should be able to tune it at any other higher wattage of power. So right now the process chamber is going on. We can see the plasma in the chamber, and the elapsed time is indicating that the process time is being timed 2 minutes and 30 seconds. At the end of the process time, first the RF will be turned off, and then the gas valves will be turned off, and the process gases are being evacuated. After that, the residual gases in the chamber are pumped out, and then the system once again goes down to the base vacuum level, which is 5 into 10 to the minus 3. That is, again, it is doing the high vacuum pump down. So once this mode is over, So if this, in the process, if the purge cycle is selected at the end, the chamber will be vented to purge it to atmosphere, and it will enable the user to open the lid and replace the sample. Right now, the second step in the process is being enabled. Here, I have once again selected the three gases, but the flow rates are different. And now the pressure stabilization is taking place. I'm demonstrating that the process pressure of 5 Pascal set point is also working. So once the pressure and the gas flow stabilizes, the RF power will be enabled. So the forward power set point is 100 watts, and it is at about so I'm trying to demonstrate how I can tune manually. So manually tune. If I press the auto button again, it will tune by itself as well. This step is a quick step of about 2 minutes, and after this step the system will either remain pumped down in vacuum condition or will purge the chamber. At any point of time, failure of any of the facilities such as compressed air, nitrogen or water flow could disable the system operation. So also, if the gas detectors are powered down, then also the system will be disabled. The care should be taken not to rush to re-initialize the system until all the problems are rectified. So that's the end of step 2. After quickly roughing through, the system will go to the high vacuum pump down mode again. It's always necessary to have nitrogen present on the system facilities, because nitrogen is used to vent the chamber and also is used to purge the turbomolecular pump. And sometimes in the process nitrogen may be desired. The system should be always operated with all the panel doors closed, and all the screws used on the panel doors are 4mm metric screws. So this indicates that the process is complete and the chamber is left under vacuum. So here it is manually possible to either let the chamber pump down or purge it in order to replace the sample. In another minute. So at this moment, this system purging is over. Now we can open the chamber door. I'm opening the chamber door, chamber lid, and this is the gas tube door after the unlock button illuminates. So this is the process break. So the system manuals for all the modules on this machine will be included on a disk, and it's always important for the user to proceed with these disks handy, and the manuals should be saved all the time. I'm going to close the door. So there are two O-ring seals on the chamber. Care should be taken to always to verify that there is no particulate matter on the O-rings here. It may be necessary to periodically replace it using a white-on O-ring. So first we have to close the door, then close the lid, and then proceed with the process.